Hello, this is Nick of Time. Welcome to this, our 24th talk in our series on the treatment of time in physics. Today we're going to be talking about a misunderstanding by relativists about the role of inertial frames in special relativity and indeed in all of physics. We're talking about inertial frames, but we'll also be talking about time because this misunderstanding of the role of inertial frames is so deep and so pervasive that it touches on most everything. And the easiest way to see this is about clock slowing. Okay, let's talk about special relativity and inertial frames. Each of these three bullets on this slide will describe a particular interpretation of inertial frames in special relativity. We start with special relativity was constructed and explicitly articulated as applying to inertial frames with transformations between inertial frames and the construct of relative velocity between inertial frames. So it was viewed as a theory about physics in inertial frames. Next, in bullet 2, special relativity began to be applied in logic discussions to cases where the non-base frame, or the so-called traveling frame, was non-inertial. And this was done without discussion as to this fundamental change in interpretation of the role of inertial frames in special relativity. This seems to be a good step forward to me to include clocks in non-inertial frames, but the problem is that even though it's a step forward, one can't really get to the right answer in the context of special relativity. So now we had two conflicting interpretations of the role of inertial frames in special relativity. And even though number 2 was a step forward, they didn't drop the first interpretation. So now we had two conflicting and mutually exclusive interpretations, both being used by the relativists. Okay, third bullet. Then all empirical data that was alleged to support special relativity was seen to involve two clock frames that were both non-inertial. For example, take a particle accelerator, and obviously the particle that's being accelerated, be it a linear accelerator or a circular accelerator, they're being accelerated. They're not in inertial frames. And the starting frame is the rotating Earth, and the rotating Earth frame is non-inertial. Now here, the relativists did not tend to explicitly say special relativity is extended to cases where both clocks are in non-inertial frames. But since they said that the empirical data in those cases supported special relativity, the clear implication has to be that that's how they're interpreting special relativity. So now we have three contradictory interpretations of special relativity, all three being mutually exclusive. And just by the way, that makes it difficult to critique without seeming to take on some of those contradictions oneself. One have to be very careful in listening to what's being said. Okay. Talking about inconsistencies, will continue. The relativist takes the position if data involving non-inertial clocks is alleged to support special relativity, that's accepted, as it's claimed that the clocks were near to being inertial. But the criterion for being near to being inertial is not defined, and that's not good physics. In contrast, the relativists hold that if the data involving non-inertial clocks is seen to not support special relativity is, quote-unquote, saved by claiming that the clocks were non-inertial, and therefore outside the domain of special relativity. And this is used even if that criterion of near to inertial is the same as for the first bullet. That's disregarded. So let's move on. Okay. Now the problems, let's look at two big problems for the relativists when they exclude special relativity from covering non-inertial frames in their effort to save special relativity from conflicting logic and conflicting data. Okay, the tact of excluding non-inertial frames implies that when an object or observer or frame has the tiniest acceleration, the laws of physics totally change instantaneously. For example, special relativity no longer applies. Not only for the frame that was inertial but then experienced the tiniest of accelerations, but for all frames moving relative to it. For example, in time dilation, we have time dilation effect is for all the frames that move relative to a clock in an inertial frame. So that's a very problematic implication of taking that tact of the relativist, taking the tact of excluding non-inertial frames. Secondly, when they take that tact, since in the real world inertial frames are rare to non-existent, it really makes special relativity worthless because it can't be applied in real-world situations. Instead, physicists should take a physics view of inertial frames. Instead of building on abstract math constructs, such as frames, and that caused many of special relativity's major weaknesses, one should focus on a viable physics model. Second bullet. Physical velocity-dependent effects should be viewed as a function of velocity with respect to a physical entity, not velocity with respect to pure math constructs, such as frames, unless that frame, a single frame, is associated with a very specific physical entity. What one should do is first develop the theory based on physical entities, and then develop math tools like transformations between frames, but not vice versa. It should not, the physics development process should not be driven by starting with transformations, or be frame driven. Okay, a better perspective on special relativity and the role of inertial frames is, rather than restrict velocity-dependent effects to inertial frames, when convenient for the relativist to avoid some logic problem or some mismatch with empirical data, specifically think that Einstein happened to use the inertial frame only restriction, and that made it easier to derive the velocity-dependent physics, as it didn't complicate his analysis by making him deal with including accelerations and forces. So the inertial frame only approach is just to make the derivation simpler and more straightforward. But once you've used that approach to derive velocity-dependent effects, then once those effects are derived, extend those effects to instantaneous velocity instead of constant velocity in non-inertial frames, to be added to effects that accompany acceleration and deceleration and forces. Okay. Another point, let's look at special relativity and general relativity in inertial frames. Part of the cause for the role of inertial frames being misinterpreted for special relativity is that special relativity is viewed as handling inertial frames, and then general relativity is viewed as coming along and extending the relativity thinking to non-inertial frames. That reinforces the misinterpretation of the role of inertial frames in special relativity. Okay, let's look at the empirical data. The empirical data from particle accelerators, high atmosphere muons, Half-Lake heating, and GPS argue for the views presented in the previous slides, and argue clearly and very powerfully for that view. An inertial frame restriction is a red herring in physics. Okay, it's clear from the empirical data that the velocity effect on clock rate is a function of instantaneous velocity for inertial and non-inertial clocks. Okay, that's today's discussion. We'll go on to part 2 and give a specific example of what we've been talking about conceptually today, and hope to see you then. Thanks for joining us today.